In the second video on section 6.6, simple interest, we're going to look at the example problem after the first video and then explore some other part of the simple interest formula. So in the example problem, again, we were figuring out the interest and the balance. This time I didn't give you a context, I just have the principal rate and time outlined. So you want to use your formula, I equals PRT, substitute in 1,000, 0.07, and 10. Your interest would be $700, and then the total balance would be $1,700. I just want to compare this with our first problem with a similar principle. Okay, so the principle was the same. It was 1,000. This time the rate was lower and the time was lower, half as long of time, 5 years compared to 10 years. And the rate was 3% lower. So if we can see, here we only made $200, but here we made $700 in interest. And again, that's because the bigger the numbers we're working with, so even though the principal was exactly the same, look at the factors of the interest rate and the time had on the amount of money that we are making. So this is one way to do these problems, where we are finding the interest and the balance. Another way to do this, though, is to solve for something that is missing. So let's take a look at problem number 3. A deposit of $500 was made for a period of 7 years. If $63 in interest is earned, how much was the interest rate? Or in this case, you could kind of set like you want to make so much money, and what interest rate could you look for, type of thing. So a deposit of $500, that's the principal. A period of 7 years, that's the time. And the $63 in interest was earned, so that's your I. And when it says how much was the interest rate, that's the R. That's what we're looking for. So we're going to still go back to our I-party formula. But this time when we go to substitute in, we actually know the interest. That's 63. The principal is 500. We do not know the rate, and the time is 7 years. So we are going to use our inverse operations to solve for R. But before we do that, remember, this is a giant multiplication problem. Multiplication is commutative, which means I can simplify this. I can do 500 times 700 times 7 and rewrite this as 3,500 times R. Again, how do I solve for R? I do an inverse. I divide both sides by 3,500. And again, using my calculator, I come up with, if my calculator will put it in, 0.018. Now again, this is the correct answer, but it's not in its percent form, just like some of those word problems we were doing the other day. So we move our decimal 2 places to convert a decimal into a percent. So we earned we had a 1.8% rate. Again, that's pretty small, but you made $63. So let's do a second example together, and then I want you to pause the video and do problem 3 on your own and just compare it. So in this problem, we know the interest was $72, the principal was $800, the rate is 9%, and this time we're looking for the time. So we do I equals PRT. We substitute 72 in for I, 800 in for P, 0.09 in for R, and T in for time. We're leaving that as T as a variable. Again, we're going to do an inverse operation, but before we do that, we want to simplify our multiplication by multiplying 800 times 9 is 72. So we get 72 equals 72T. If we divide both sides by 72, that gives us 1 equals time. So the time is 1 year. I want you to pause the video, try problem 3 on your own, and then come back and look at my answer. Oh, we have 3 and 4. Oh, good. So try 3 and 4, pause the video, and then take a look at mine. So after looking at this, I think let's do problem number 3 together. I'll show you problem number 3, and then we'll do problem number 4 together. So in this problem, problem number 3, we're looking for our principal. How much money did we put in the account to begin with if we earned $90 at a 5% interest rate for 4 years? So I take 0.05 times 4 to simplify. That's 2/10 or 0.2. Dividing both sides by 0.2 gives me $450. And one thing I want to note here again is that you can always check your answer by going back to your PRT formula. So if we substitute 450 in for P and we multiply that by 0.05 and by 4, we should end up with 90. So we're always able to kind of check our work and to make sure it makes sense. So let's look at this last one. Miss Lombardi borrowed $35,000 to remodel her house. At the end of the 5-year loan, she repaid a total of $46,375. What simple interest rate did she borrow the money? So she borrowed $35,000. That's her principal. At the end of the 5-year loan, that's her time. Now, this is a little bit tricky. She repaid a total of $46,375. That is not the interest. That is the balance. So in this problem, we actually have to do an initial step first, where we know that the balance is the principal plus the interest. So that means the $46,375 is the principal plus some interest amount, and the principal is $35,000. So to get the interest, we're going to do an inverse operation here. I know you can just subtract the two numbers, and I think that's fine. But I also think it's really good to reinforce the fact that we're using inverse operations to solve for unknowns. That's one of the things that we are working on as an overarching skill this year. So this gives us an interest of $11,375. And now I can use that in my simple interest formula. Go ahead and simplify and multiply 35,000, that's your principal, times 5, that's your time. And then go ahead, and this time our inverse is division, right? Here we were adding, so our inverse is to subtract. Here we're dividing or multiplying, so our inverse is to divide. So every problem is unique. We have to kind of look at each one as we go. And remember, we expect to get a decimal here because we're looking for the interest rate. And then we go ahead and move that decimal 2 points, 2 places to get it. And it's a 6.5% interest rate. So also, I just want to look at this really quickly. This interest rate, 6.5%, is pretty high. The loan was only for 5 years, so that's a pretty short amount of time. But I want us to look at, so Miss Lombardi borrowed $35,000 to remodel, which is a lot of money, and she ends up paying $11,000 in interest. So think about that. She only needed $35,000, but she had to pay back $46,000. And this is, again, when we borrow money, we want to borrow it at a low interest rate and for a shorter amount of time to pay back the least amount of interest possible. But when we invest money or save money for the future, we want to put as much money as we can at the higher interest rate we can for the longest amount of time we can, because that's going to make us the most money. So those are the two sides of the coin when you're working with interest. So now go ahead and you can try the second homework assignment associated with simple interest, and we will go over that in class.